Hi everybody. So in this video I want to talk to you about measuring temperature. And there are a variety of ways in which we could measure temperature, but the one we're going to look at today is using a device known as a thermistor. And what a thermistor is it's a temperature dependent resistor. So we could draw it kind of like we did for the photoresistor. I'll draw it like this, and I'll use the abbreviation TR for it. So a thermistor is something whose resistance changes based on how hot it is. Very similar to the photoresistor, whose resistance changed depending on how much light was on it. In the case of the thermistor, if the thermistor is hot, that corresponds to low resistance. If the thermistor is cold, that corresponds to high resistance. The exact reasons for this aren't particularly important to get into at this point. There's some really interesting solid-state physics that this relates to, and you could of course look that up. But for now, this is good enough for us, that as the temperature of the thermistor changes, the resistance changes, and in particular, as it gets hotter, the resistance decreases, and as it gets colder, the resistance increases. Now, in order to measure resistance, we need to incorporate this thermistor into a circuit. And the circuit that we'll use again is a voltage divider. So the voltage divider we'll use a fixed 5 volts from the Arduino, and then we'll go down through the thermistor, and then there will be some fixed resistor here. We'll take the midpoint of this voltage divider and we'll send that out to the Arduino. So looking at this, let's see what kind of behavior we have with this. So remember, just to refresh, with a voltage divider, when this top resistor is small, then this output gets closer to the 5 volts. When this top resistor is big, then this output here gets closer to ground or 0 volts. So when the thermistor is hot, we have a low resistance here, so this is going to be closer to 5 volts. So when it's hot, we're going to be closer to 5 volts. And when it's cold, we have high resistance, so that means the output to the Arduino is going to be low, close to 0 volts or ground. And of course, if it's neither at the extreme hot or extreme cold, it'll be somewhere near the middle, and then you can see the fluctuations around there. So I'm going to go ahead and build this circuit and show you what this looks like and how we can read it into the Arduino and how this works in the real world. So now let me show you what a thermistor looks like in real life. So this guy right here is the thermistor that comes with the Arduino Super Starter kit that we're using for this series. And it consists of this black head here, which is the region that is sensitive to the temperature. So as this black nub here gets hotter, the resistance decreases, and as that black nub gets colder, the resistance in it increases. It's of course got 2 legs coming off of it so that you can connect it between different circuit elements. So let me go ahead and hook it up to the Arduino in the voltage divider configuration, and we'll see what we can do with it. Okay, so now I've got my thermistor hooked up in a voltage divider configuration using a 10K fixed resistor. So walking through this configuration, what I've got is I've got, of course, my ground and 5-volt cables, ground being blue, power being 5 volts, going to my plus and minus power rails. I've got one end of the thermistor connected to the positive 5 volts. The other end is connected to one end of my fixed 1K resistor, the other end of which goes back to ground, forming my voltage divider. The midpoint of this divider, connected by this orange cable, is going into my analog channel A0. Now I've got the Arduino code up as well, and if we walk through what that code is doing, it's exactly the same thing that we were doing when we first encountered the photoresistor. So in the setup, we've got this serial begin command. This is initializing serial communication with the computer. I'm reading in the value, entering channel A0 with the analog read command, and I'm going to print that value to the serial monitor. So let me go ahead and pull up the serial monitor, and I'll show you what we're getting out of the thermistor. Okay, so here's the output of the serial monitor. Remember, it's measuring right in between the thermistor and the fixed 10K resistor. And this value, remember, it scales from a low end of 0 corresponding to 0 volts and all the way up to 1023 corresponding to 5 volts. So right now it's sitting a little bit below 500, so it's sitting somewhere close to 2.5 volts, something like that. So kind of nicely centered in the middle of our range. Now this, if I heat up the thermistor, this number should increase as we go to a higher voltage. If I cool it, this number should decrease as we go to a lower voltage. So to heat it up, I'm just going to grab it with my finger, use my the body heat in my fingers to warm it up. It's not going to go hugely higher, but it should be enough that we can see. So let me go ahead and pinch the thermistor, and you can see it's getting almost up to 600 degrees, maybe right around, or not 600 degrees, up to 600. So it's definitely increased. I'll take my finger away, and it'll slowly cool back down to room temperature as that heat is radiated away, and we'll see it get close to 500 again. The next thing I'm going to do is I've got an ice cube in a little plastic bag, and so I'm going to try to cool it with this ice cube you see I've got, and let's see if we can make it go below. And you can see not a huge amount. Let's see if I can get my finger away. I can get it down to 300, maybe even a little lower, maybe down to in the 200s, something like that. So maybe right around 300 because of the ice cube cooling it. Bring that away, and now it'll warm up, and see it return back to room temperature, just a little bit below 500. So this is the basic configuration that we use the thermistor in, and you can see how we can use that to measure the temperature of our surroundings.